Categorical syllogisms, as we already know, form a major class of deductive arguments. Evaluating categorical syllogisms is enormously complicated. For about 2,000 years, philosophers worked out the various ways of evaluating categorical syllogisms, and this is pretty complicated stuff. I am not going to expect you to learn all of this complicated stuff. However, in this presentation, what I'd like to do is give you just a few basic simple rules of thumb that you can learn really fast that can make your life a lot easier. These rules will not tell you which categorical syllogism is a valid one, but they automatically show you that a given invalid argument is invalid. If a categorical syllogism violates one of these rules, which I will be giving you, you'll know automatically that it's invalid. So we learned about the various types of deductive argument patterns previously. Categorical syllogisms are deductive arguments, and what characterizes them is they have at least one categorical statement within the premises. And a categorical statement is a statement about a category of things, like all roses are red. That is talking about the category of all things that are roses. Or no roses are green. So words like all, no, some, or some are not, as in the phrase, some mammals are not birds, for example. Those are all examples of categorical statements, and a categorical syllogism contains at least one of those. Now, in order to teach you these basic rules that I want to go through with you, just a couple of pieces of terminology are necessary. The words all and no are universal terms, what we call universal quantifiers. Because when you say all dogs, you're speaking universally about all dogs that exist always and everywhere. And similarly, if you say no dogs are whatever, then you're talking about all dogs again, but you're saying something negative about them. When we use the word all, this universal term, all is affirmative. It's affirming a quality of a group or a category of things. And the word no is negative. So we have a universal affirmative, that's all, and a universal negative, that's no. And complementing these, we have some and some are not. These are not universal quantifiers. These are what we call particular quantifiers. Because when I say some dogs are hairy, whatever, I'm not talking about all dogs. I'm just talking about these particular dogs over here. So the words some and some are not isolate a particular group within a larger universal group. When I say some dogs are X, I'm making an affirmative statement about that subgroup of dogs. And if I say some dogs are not cats, for example, I'm making a statement about a subgroup of some dogs that is a negative statement. They don't have a certain property, in this case the property of being cats. So not to make this too complicated, the words that we're looking for to identify categorical arguments are all, some, no, or some are not. These phrases can be affirmative or they can be negative. So evaluating when a categorical syllogism is valid is pretty complex. There are many different techniques you can use to do this. There are things like Venn diagrams, for example, that are useful. You might be familiar with these diagrams where you have circles that overlap and then you shade the areas where they overlap, and that is a very helpful technique for determining whether a given categorical syllogism is valid or not. And medieval scholars, following the tradition of Aristotle, had worked out a system of rules for valid categorical syllogisms, and I forget how many rules there were. I think there were 16 different structures that qualified a given categorical syllogism as valid. And so if it met that, if it followed that particular pattern, then it qualified as a valid argument. But that's a lot to learn and a lot to try to keep in your mind, and I'm not going to ask you to do that. There are, however, some simple rules we can use to determine whether or not an argument is invalid, and that's going to be our focus for the rest of this presentation. So here's an example of a categorical syllogism. No geese are felines, and some birds are geese. So some birds are felines. Now, you can perhaps determine that this is an invalid argument if you have learned the earlier rules that I taught you, which implies that a valid argument cannot have true premises and a false conclusion. In this case, it is true that no geese are felines, and it's true that some birds are geese, but it's false that some birds are felines. So, by definition, this would have to be an invalid argument. But there are many categorical arguments that are way more complicated than this, and they don't fall into this simple rule where true premises and a false conclusion makes them automatically invalid. However, there are some simple rules of thumb we can follow that can help us to determine immediately that an argument like this one is an invalid argument. This argument is invalid, as we will learn, because it has a negative premise, the negative universal statement, no geese are felines, but there's no negative statement in the conclusion. So one of the rules we will learn is if you have a negative premise, you must have a negative conclusion. There has to be that balance there. Here we have a negative premise, but we don't have a negative conclusion, so it's automatically invalid. And all the trouble we might have to take of thinking it through or evaluating the truth of the premises goes by the wayside. We apply the rule of thumb, we get the right answer. This is an invalid argument. Let's look at some of these rules now in some more detail. So here are the 4 basic rules I'm going to teach you that can tell you automatically if a given categorical syllogism is invalid. First of all, if you have a categorical syllogism with 2 negative premises can begin with no or with some are not. Regardless, if you have 2 negative premises, that argument is automatically invalid. That's an easy rule. We'll look at some examples in a second. If you have a negative premise, like in the previous example we just looked at, then you have to have a negative conclusion. There has to be that balance. A negative premise requires a negative conclusion, and a negative conclusion requires a negative premise. So if you see a negative statement in the premises, you have to look for a negative statement in the conclusion. Now, of course, if you have 2 negative statements in the premises, well, that would violate the first rule. Right? So these are handy markers for telling us if an argument is invalid in a very simple way. If you have 2 premises that are universal statements, all or no, like one all statement, for example, in a premise, and one no statement, well, then you know that the conclusion cannot be a particular statement. So 2 universal statements in the premises cannot lead to a particular conclusion. And the other rules apply as well. If the 2 premises are universal statements and they're both no statements, that would violate the first rule. So some of these rules will be violated more than once by a given example. And finally, 2 particular premises. Some dogs are cats, or some dogs are not mammals, for example. You can't have 2 particular premises in a valid argument. So keep that in mind. There are no simple rules for figuring out whether an argument is valid, but if you apply these simple rules, they will tell you automatically that a categorical argument is invalid. Let's look at a few examples. So here's an example of a violation of the rule that 2 negative premises are not allowed. No dogs are cats, no cats are fish, so no dogs are fish. Now, the rule of having a negative premise, if you have a negative conclusion and vice versa, that's not violated. But here, 2 negative premises, automatically invalid. And here's another example. All fish are cold-blooded. Some cold-blooded creatures live on land, so no fish live on land. Here, the conclusion is a negative statement. No fish live on land. But when we look back at the premises, we see that they are both affirmative statements. So there's no negative premise to balance out the negative conclusion, so this argument is automatically invalid. So So I hope you can see how simple this is. Let's look at another example. All mammals are animals. All unicorns are mammals. Therefore, some unicorns are animals. Well, here, the rule that is violated is that you have two universal premises, but you're drawing a particular conclusion. That is not permitted. Two universal premises cannot lead to a particular conclusion. Therefore, this is an invalid argument. And our next example, some people are tall, some people are short. Consequently, some people are both tall and short. Now, this should be, I hope, obviously invalid to you because the premises are true and the conclusion is actually false. So by definition, it must be invalid. But it's also easy to see that it's invalid because it has two particular premises. Two particular premises in a categorical argument are not allowed. That makes the argument automatically invalid. So you can determine that this argument is invalid using a number of different ways, but having a rule of thumb makes it much more convenient. So I hope you find these rules useful for dealing with categorical arguments, which can be tricky and a little bit confusing. I would recommend, before you go do the few practice exercises that I've posted, that you try to create arguments that violate some of these rules, and that will help you not only learn the rules, but also be able to recognize the flaws in a given invalid argument. And that would be very helpful, especially on future quizzes and exams. All right, and so now this is going to be the end of our conversation with respect to validity. There's more to validity, a lot more, but I'm not going to present it to you. It's way too complex. In a logic class, for example, you would go into much more detail in a lot of this stuff. However, at least you have enough information now to accurately evaluate deductive arguments. So it's time to practice.